Hello. So this is our report from iteration one. I'll go through the 3 points or requirements that we had not met in our first iteration. Starting with the first requirement, it says when a city has accumulated enough production, it produces the unit selected for production, and the unit cost is deducted from the city's treasury of production. The unit is placed on the city tile if no other unit is present. Otherwise, it is placed on the first non-occupied adjacent tile, starting from the tile just north of the city and moving clockwise. So to address this, let's first check if this happens without our code. So here I start a game implementation. I give it a position. This position correlates to, I believe, Red City, Red City's coordinates. And then here we check if there is a so is tile occupied function basically here in our city, no, in our game implementation, um, is occupied basically goes to our unit map, which in our iteration one video we have explained how that is where we keep track of all of the units on the map. So it basically checks if that specific position has any units or not. Um, so in our test case here, the city position should not have, when starting, should not have a unit on it. So it will be false. And it will go through 2 rounds, and each round from our iteration one, we have made it so that after each round, the treasury earns 6 points production, 6 production points. So after 2 rounds, it will be 12 total production points, which will be enough to buy a archery, which is our set unit for now. So after 2 rounds, we should have enough for us to buy a unit of archer. So on this test case, for now it should fail because we don't have the code set up for it. So here in our game implementation, no, in our city implementation, inside of our produce function, we have set up a if statement where we check if the treasury has enough production points to produce the unit that we have selected. For now, it's just Archer, which requires 10 production points. So whenever it reaches to a point where it has enough production points, it sets off this if statement where inside of it, it deducts the point, however much it's going to cost to produce that unit, as said in our requirement here. Um, it produces the unit selected for the production and the cost is deducted from city's treasury. So we have met all of these things. Um, so here it basically deducts, and we have a boolean set up to check if the city is ready to produce a unit. So after this is set true in our game implementation, where after each round we are producing here, we tell each city to produce their required amounts, which would be 6 units. So not units, 6 production points, and then after which here we check if each city has enough points to produce any units or not. Here you can see that Red City is checked for its production readiness, and if it's ready, we go inside of place unit in or around the city. This correlates to the second half of our requirement, which is the unit is placed on the city tile if no other unit is present. Otherwise, it is moved to the first non-occupied adjacent tile, starting from the tile just north of the city and moving clockwise. So here in our test case, we are testing if after the second round, if the game places a archer on the city tile or not. So after uncommenting this code, it should go through place unit in and in or around the city, which takes us here, where it basically checks if the position that we have given is taken or not. So for now, for the first one, it would be city production, position. It will check the city position and make sure that there's no other unit present. If there's no other units, if there are no other units in that position, it basically places our new unit in there. And if there is some other units already present in there, we move on to north tile from the city, and then start to move clockwise from there, which is done with the adjacent tiles here. So we get all of the coordinates of the adjacent tiles, and our for loop basically goes around all of those, which makes a clockwise move. And whenever it finds a unoccupied position, it just places our new producer unit in that position. So if we go back to our test case, this should pass now. Um, okay, that test case passed. Also, let's check to make sure that it does indeed not only work for the city position, but also the north tile, just to make sure that it is going north after replacing the city unit. So on this one, we had 4 rounds total. The 2 rounds would make it so that it places on the city position, and then the other 2 rounds are making it place on the north block from the city. After that, uh, so that basically takes care of the whole first point. And then our second point is aging for the game. The game starts from 4000 BC, and each round advances the game by 100 years. So in our code here, um, we let's go to the test case first for our TDD. Um, so let's see. Okay, so here we check if the position does start with negative 4,000. So if we want to make sure that it does start with negative 4,000, it does. Negative 4,000 basically correlates to 4,000 BC. And then after that, we should advance 100 years, as said in our requirement here. Advance 100 years after each round. We This test case is basically for that. We make sure that it does advance the game by 100 years. If we run this test, we see that the test fails. It does not get to 3900, negative 3900 after 1 round. So let's go to our game implementation and end of round function here and see that we have commented out the advancing feature here. So if we uncomment that and go back to our test case, we can see that it does indeed pass. This happened because we added 100 to our negative 4,000 after the end of the round. So that takes care of the second point in our backlog. For our last one, winning for red wins in the year 3000 BC. So to get to 3000 BC, we'll have to go through 10 rounds or 20 turns, which is exactly what we have here. So for now, if the game starts and goes through 10 rounds here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so if it goes through 10 rounds, it should be negative 3900, and then go all the way down to negative 3000 here. And then at that point, red should win. So if we check it, let me also put it here up top here just to make sure that the game that red didn't win at first. Okay. So if we run this, it should turn out to be false. Or I mean not false. The test should fail. So the test fails. Let's go to our game implementation and make sure this is uncommented. Here we have if we have a if statement where it checks if the current age of the game has reached negative 3000 or not. If it has reached negative 3000, we declare red as the winner. The red one is basically a boolean up top here, or boolean variable, which is set as false at the start of the game. And then when the game reaches negative 10,000, negative 3000 or 3000 BC, we declare red as the winner. Let's see. Let's go back to the test case, run it, and it does pass. Okay, so that takes care of all three of these points, and we have, I think, gone through all of the things given to us for iteration 1 and 2 from the book. That's it for today. Hope you guys enjoyed the video. Thank you. Like, share, and subscribe.